Hello everybody and welcome to the 10th lecture of MIA 320. Uh, During the last couple of weeks, we talked about engineering, society and industry. We also talked about the engineering and environment. In this lecture, we are going to start another section which is focused on managing the impact of engineering. Uh, this week we are going to speak about risk, but next week we are going to speak about ethics, Occupational Health and Safety Act, and sustainability. But the important thing is, like all those concepts or topics, let's say risk or ethics, they are not like a very simple concept that can be covered in a 40 minutes time. So we are trying our best to cover as much as we can, but you should know that those topics, they are field of study by their own. Okay, so um, during this lecture we are going to talk about what is risk, perspective on risk. We are going to just like talk about perception of risk as well, and we are going to a little bit talk about risk management. So first, before talking about risk, we need to define some like words that we use. For example, hazard. What does it mean? Hazard is anything that could possibly cause harm. But when we are defining it as anything that can or could possibly cause harm, it means that the number of hazards are almost endless, because everything might, under some condition, cause harm. But there are some like safety acts. So here there are two safety acts that you can refer to. We are going to talk about them in 2 weeks time, but here I just like mentioned OHSA 93 of 2004 and MHSA 29 of 1996. Every country has some kind of regulation in terms of like hazardous material or what are to be considered as hazard. South Africa has the same as well, so you need to follow up on that and to understand the local law and regulations. But of course there are some international as well, so you are familiar when you are flying, so you can't take hazardous material or object into the plane with you. So there are some regulations that they are universal or international, and sorry, and there are some that they are local. So risk basically is means the probability that one injury or damage will occur. So again, is like there are different regulations that, as you can see here, OHSA 93 of 2004 and MHSA 29 of 1996 and the ISO 31,000 of risk management. They defined it differently. For example, for OHSA 93 of 2004 defined risk as the likelihood that occupational injury or harm to a person will occur. For in MHSA 29 of 1996 is the effect of uncertainty on objects, and in ISO 31,000 risk management defined as either positively or negatively. You can refer to these regulations. You can go through them and study them if you are interested, but here we just like scan through them. We are not going to go into them into detail. But so for example, we said that we define the hazard that anything or object that could potentially cause harm. So then we also said that if we accept that definition, it means that the number of hazards are countless, because everything can cause some kind of harm under special circumstances. So basically, we also know that it is impossible to remove all the hazards. Uh, some of them cannot be removed. For example, let's say, just very simple example, you need a knife inside your kitchen to cook, but at the same time that object considered as a hazard to kids. So can you say that I don't want to have a knife in my kitchen? It's not possible. So there are some restrictions regarding dealing with hazards as well. But in dealing with them, we need to institute some kind of acceptable amount of risk. Okay, because we say that is like we want to walk toward to zero harm. We also said that we can't remove all the hazards. So all the time we are dealing with the level of risk. So you can't do anything without risk. Okay, even like, I don't know, crossing a street is a kind of like a risk, or eating food is a kind of like a risk, because some people might die during the time that they are eating food. So anything that we do associated with some kind of risk, but the most important thing is that risk, the level of that risk needs to be acceptable. So how we are going to measure it? So basically it's a risk based on the cost. Okay, so for example, if it's a kind of balance that we need to apply during the time that we are thinking about risk management. And why it is important that we keep it, we pay attention to it as engineers, because it's really important. Why? First, the reason is that you as an engineer, you are designers, so you are going to design something for maybe even daily life of the people. So it's very important to be familiar with this concept. But of course, when you are going to design some kind of products, if a company wants to produce and then sell it, there are many regulations, like safety regulations, that they need to address before being able to sell it. But just like keeping in mind that it's a very important concept. The risk cannot be zero, but always we are dealing or living in a world that all the time we are accepting risk, but the level of that risk is acceptable in a way that, after considering the risk and the cost, so we get into a balance. But we said that acceptable risk. But what are the acceptable risks? So fortunately, it's not something that people can decide on their own what is the acceptable risk. So there are, like, as I said, many governments, they have their local law and regulations regarding safety and risk. So we are dealing for international as well. For example, if you are designing something here and you want to sell it in Germany, so of course you need to, on top of, because you are producing in South Africa, you need to address the South African domestic law and regulations, but at the same time the country that you are trying to sell your product. here you see that we just categorize them into three different categories, like personal hazards, environmental hazards, and societal hazards. Personal hazards are normally regulated, are regulated by OHSA and MHSA, and some subsequent regulations we talked about. I just gave the number, but we can't go into them into detail because there is no enough time. But environmental hazards, if you remember, we talked about air pollution, and we just also talked about water pollution, and we also said that in different countries there are different regulations regarding the clean air, or even what is acceptable for water to be potable. So there are different things in the South Africa Clean Air Act, dust control regulations. So there are many regulations associated with environmental hazards, especially during the last couple of years, that uh, governments understand the impact of environmental hazards and how that can affect on the society. But societal hazards are a little bit more difficult compared to quantify and regulate. For example, for air clean act, it's not easy, but it's much easier because you can put a particle ppm. Or for water, yes, you can say that if the water salinity is higher than this number is not acceptable, is lower than this number is acceptable. So, or if the dissolved oxygen in water is lower than this particular number, is not good. So there are some quantity that you can compare. But for societal, it's different. It's difficult to deal with it because there is no quantity. But there are some, but not all the countries they follow. For example, in the US, it's not a regulation, but it's like an acceptable law that if no, it's not a law because there is no regulation, but people, especially economists, say that if 21% of one market is in the hand of less than two companies, it means that there is a kind of monopoly happening in that field. But let's just a little bit talk about environmental hazards, Air Quality Act, and regulations. Air Quality Act states that, so there are some, as I said, there are the numbers. So dust fall rate, you see that it's you can quantify it easily. Here it's just we are talking about acceptable dust fall rate restrictions per for 30 days average. For residential area, it should be lower than 600, but for non-residential area, it's between 600 to 1,200. So you need to go into those regulations to understand it much better. But here we are here to give you just a perspective about risk. To continue on the same subject, that talking about the acceptable risk, we say that first, often legislators will select a risk level as a baseline. But you might say that, okay, for example, somebody is in who are legislators? So government or parliament. But if you look at that, mostly those kind of regulations come from scientific departments. For example, it's not like that somebody, for example, I'm Ministry of Defense, for example, I come up with some kind of legislation for air, clean air. No, there are like environmental agencies. They have a scientific section. There are scientists that they work for governmental departmental organizations. So they go through it. They do uh, like a research. They come up with some kind of like a suggestion. That suggestion goes into the parliament. Most probably sometimes that politicians, they have this power to force those governmental agencies to compromise, and after that it becomes legislation or law or regulation, and after that everybody had to follow it. uh, but it's like there are the other thing that is important is about environmental risk assessment, because uh, there are different the society is not completely not everybody in the society thinks the same. So maybe restricting some kind of like activity for you is a good thing, but for another person is like a way of making money for life. So governments, they play a very big role there to assess those kind of like environmental risk, and after that come up with some kind of regulations to minimize or decrease the probability of some harm. The other important uh, topic that we would like to talk about is perspective on risk. The common start point to start about and describe of risk is to point out that there is some kind of risk hidden in everything, as I told you. Just think about the fact that all human beings die someday. Okay? So that makes the risk of dying over our lifetime to be 100%. Okay? So it is easy to gather data like that, which is shown in this table here, leading causes of death in the United States in 1992. We are going to show the updated results later, and I want to just like give the same perspective, and after that compare it with South Africa later during the same lecture. But look at the second line, which is cancer. Uh, it's as you can see, this table shows that in 1992 in US 527,000 people died out of 2.18 million predicted deaths in US due to cancer. Without considering the age, structure, complication, or stuff like that, we can say that on average the risk or probability of dying someone in the US from cancer is around 24%. Why I mentioned this table? Because it's the same table that we have in our textbook. Later, as I said, I'm going to show you the more updated results, and if you see here and you keep it in mind, those kind of rates are more or less the same, so it didn't change a lot. There are some differences, but generally is the same. Again, cardiovascular diseases and cancers are the most important or reasons of deaths in US or some other countries. We are going to compare it with South Africa as well. As you can see here, there are no units associated with risk. So normally it is like sometimes we say it based on the percentage, sometimes between like a number between 0 to 1, and we use the probability to describe it. Our textbook is focused on healthcare field, but often risk is simply qualitatively described using the risk level or risk factor. We are just like going to talk a little bit more about it, but perspective on risk in terms of healthcare, uh, we need to keep it in mind that we said that for no units, but how does it work? For example, here, uh, whether the risk is a lifetime or annual risk, whether the risk is an average risk to the public or a risk faced by individual who engage in some activity. Uh, we don't know anything about it, so that's another important thing that keep in mind. For example, both air pollution and smoking cigarette cause cancer and eventually death, but there is a difference between them, so we can't just like compare both of them exactly the same category. Uh, Presenting the risks as an annular probability of death to individuals who engage in some special activity is a much more specific way to express risks than simply looking at the population as a whole. Just look at this table. As you can see, the probability of dying in a motorcycle accident among those who ride motorcycles is 2,000 deaths per year per 100,000 motorcyclists. So it's quite high. But if you just like say that yes, for example, 2,000 deaths per year divided by population, maybe it's a very small number. But when you get very specific and you say that yes, 2,000 out of 100,000 that they ride motorcycle or motorcyclists, so that's another story. Another example is the risk associated with consuming 4 tablespoons of peanut butter per day. It turns out that mold on peanuts create a group of chemicals called aflatoxins. They are known to cause tumors in a number of animals such as rats, but FDA, Federal Food and Drug Administration, restricts the aflatoxin concentration in peanut products to 20 ppb. What is 20 ppb? Is particle per billion. Just think about that. It should be 20, less than 20 particle per 1 billion particle to be accepted from the Food and Drug Administration. So it's important. If you are producing peanut butter, it's like you are an engineer and you say that yeah, I don't care. No, when you are designing a machine for that industry, those numbers are important and you need to be aware of those things in order to be able to come up with some solution to address the problems of that industry. This slide is another slide, so shows another table that it's from the textbook. I'm not going to go through it, but you can find more information and read about it in your textbook. One of the purposes of risk assessment is to provide a starting point in balancing the trade-offs between an acceptable incremental risk and the cost of controlling that risk. This table, again from your textbook, shows some estimated expenditures to prevent a life from being shortened by a year. For example, immunization and removing lead component from gasoline are indicated to have no cost because the direct saving in the healthcare system for far exceeds their implementation cost. So we have an implementation cost, and after that, like when we look at the cost benefit, it is like far exceeds the implementation cost, the benefit of immunization and removing lead component from the gasoline. But on the other hand, saving lives by controlling dioxin at the paper mill is very costly. So It's is like there are lots of things to consider. Is always it's a balance or trade-offs between acceptable incremented risk and the cost of controlling it. Uh, Now it's time to speak a little bit about perception of risk. Uh, I'm going to just like talk a little bit more about it because it's something that it's important in terms of like engineering design. So it is normal to see that people have different perception about a topic. And that is the reason why we need to talk about the perception of risk as well, because different people see it differently. For example, as an engineer, you might see some kind of like a risk or perception of the risk differently from another person or normal person. So sometimes this an engineering perception of risk is different from those who are exposed to it. For example, you are sitting in your office and you are designing, for example, you are designing something for, I don't know, like a kind of coal power plant. So your perception of risk is different from a person who is living 1 kilometers away from that power plant. Social scientists worked on this issue because it's not an issue that engineers can sort. So humanity, because we are humans, we are living in a society. So social scientists worked on this issue and concluded that there are a number of attributes of risk that can increase the anxiety level of someone evaluating his or her own personal exposure. So, for example, what does it mean? For example, people are more likely to be outraged when they have no control over the risk they are exposed to, compared the time that they are familiar with the situation. Uh, let's say, but look at this table. I'm going to talk about it a little bit more to say what is the difference and what am I talking about. This table here shows this notion by comparing attributes that seem to be associated with elevated perception of risk. So please go through it and compare those things. But when we are speaking about perception of risk, and I just mentioned that people are more likely to be outraged when they have no control over the risk they are exposed to compared to the time that they are familiar with the situation. Just think about the car. Are you afraid of driving car? No, of course you are not, because it's something that you are familiar with. But is it the chance of someone dying in a car accident is higher than dying in a like an airplane accident? Of course it's far far higher. You can't even compare those two together. But because it is you are familiar with the situation, if there is a like accident happens, no media covers it. But when there is a like a plane goes down, everybody talks about it. Media are all over it. Why? Because it's not something, it's like no control over the risk. So it's a situation that we are not familiar with. The same story can happen, for example, if they are saying that you have two options. You can live 1 kilometers away from a nuclear power plant, and at the same time you have an option to live 1 kilometer away from like a coal power plant. Normally people say that, yeah, it's cold, I'm familiar, I was there for a long time, nothing happened to me. So you choose the second option. Why? Because the consequences are a little bit familiar for you, while maybe the consequences of nuclear power plant and what will happen to the soil and the water in that area is not completely clear for you. It's the same story that even nowadays you heard a lot about the vaccines. So if somebody comes and say that yeah, there is like a vaccine, you can just like take it, you are not going to accept it immediately because it's something new, you are not familiar with it. So that's a reason there are very high standard and regulations, but at the same time you have no problem by uh, flu shots. So why? Because you are familiar with it, you know about the consequences, you took it like 2 years ago, so you are familiar with that risk. But these kind of perceptions can be very frustration for technical community. Why? Because when you are talking about numbers and after that, it's really difficult to convince people that say that yes, there is a nuclear power plant. It's just the only thing that it's going to happen to the water resources close to you is just like increasing the temperature, because they are the secondary systems, not nuclear material will be in touch with water in any time. But you also need to, or not you as a engineering community, we need to think about that society perception and try to convince. But of course, it's really important to not be frustrated and try. Uh, its other thing is about uh, let me just cut it a little bit here because we don't have a lot of time left, and I just want to compare this the number of deaths by cause in United States in 2017. That's I'm going to after that I'm going to talk about South Africa as well. You can see the same thing that I told you. Cardiovascular diseases and cancers are by far the main reason of deaths in United States. How many people died from cardiovascular disease in US? 900,000. How many from cancer? 700,000. Okay? But just go down, go down, go down, go down, go down. How many people died in 2017 from terrorism in US? 95. Just think about that, 95 compared to 900,000. Another thing, how many people died from drowning in United States in 2017? 4,280 compared with terrorism 95. But just think about the media coverage. When you are talking with numbers, nobody is talking about suicide, 48,000. Parkinson, 30,000. Homicide, 20,000. Hot and cold exposure, even higher, or even TB, 939. Okay, so it's really frustrating for, in this case, let's say for people that they are working biomedical industry, because that's the main cause of the country and they want more money, but because of the perception of the society, it's difficult. So the government, based on the perception of the society, they are willing to spend 10 times of what they spend on something that kills 1 million American compared to something that causes 95 or 100 deaths. Now look at here. This data shows the number of deaths by cause in South Africa in 2017. So again, you see by far HIV/AIDS is the main causes of deaths in South Africa. followed by cardiovascular diseases, cancer, uh, diabetes, TB, homicide, road injury, and there are many other things: malaria, conflict, terrorism, natural disaster, and all those stories. So, but let's just go into it a little bit more into detail to see what numbers are telling us. Uh, TB. TB is it's bacteria. I don't know if you have heard about it, but developing countries they are dealing with it, even though some developed country as well. So just think about that, the comparing between homicide and TB. 19,000 compared to 15,000. So of course both they are more or less in the same level, even though the TB is higher, 19,624. But just how much media coverage TB gets, how much the media coverage the other one, or even road injury. So those kind of information, that's something that you need to think about it, and especially when you are designing something, coming up with some kind of real solution for some of the problems. So as an engineer, you know it. For example, the chance of a person in South Africa being killed is less than dying out of HIV or cardiovascular diseases or cancers or diabetes or TB. Especially like diabetes, you see that 22,654. But there is no enough attention because diabetes is a lot related to the diet and what you eat. So lots of those 22,654 deaths could be saved. Okay. So those are some examples. Is even, you see, it's very funny example is shark. The number of people that they die due to shark attack is far, far, far less than people that they die by cow attack in the world. But nobody talks about it. Everybody is afraid of sharks, even though the numbers are saying differently. Or even is you see that even like a lightning, the chance of somebody dies from lightning in the world is higher than the chance of a person in the world of 8 billion people dying out of terrorism. It's a kind of numbers that we need to change a little bit of a perception, especially in the engineering work and design. In this slide, I try to go a little bit faster and into those remaining slides. Risk management consists of the following 4 steps, namely hazard identification, risk assessment, mitigation, minimization of risk. But risk management on itself is a field of study. People go and just study risk management for their entire life. So it's not something that can be described in one lecture or one slide. And there are many other steps in between that can be taken. So you might say that no, I went through another textbook and it was not 4 steps, it was 5 steps. Sorry, another person says that no, it's 6 steps, but it's we can accept it as 4 general rules in mind, since they are the main steps, although there are many other variations based on what kind of risk we are talking about can be found in literature. even in our textbook, which was that risk management based on the healthcare risks, that it's different from what I mentioned here. But these four steps are important because they are the main general steps. For example, if we want to talk about, as I said, or textbook to talk about the exposure of some number of people to some combination of chemicals, so the steps might be different. You can find it in your textbook. And this figure also shows another different way of thinking about it, like evaluating risk and analysis of risk, identifying it. But for example, all of them, they are in the risk assessment, after the monitoring, review, establish conduct. So there are, as I said, it's a field of a study on its own, and there are many other variations. But keep that four process in mind because there are the general ones. This video provides a good insight into the risk assessment. We are a little bit short in time, so we can't play it here, but please go and watch it. It's a nice video that provides a good insight into the risk assessment with a practical example. The rest of the slides you can just like go through it because we are already past the 40 minutes threshold. So the rest of slides are going to be for self-study. It's a very important topic. I suggest you to go through the textbook, read it. If you can find any kind of like a supplementary document, I really suggest you to do so because it is an important topic that you are going to deal with it a lot, especially if you want to start working as a professional engineer in industry, and those information can help you a lot. Okay, thank you so much for your time, and see you next week. Bye bye.